Next, I want to talk about humidity. And humidity in general is how much water vapor is in the air. And there are three different ways that we can look at this. We can look at the maximum humidity. The maximum humidity is the amount of moisture that is possible to be in the air at any given time. The maximum humidity is going to depend on temperature, because when the air is warmer, it can hold more moisture. When it's colder, it can hold less. Now, the actual amount, like in whatever units, grams or gallons or whatever, that is called the specific humidity. So we have the maximum humidity, how much is possible. We have the specific humidity, which is how much is actually in the air. And then we use those two to calculate something called relative humidity. Relative humidity is a ratio or fraction or percentage would be the better term, of how much moisture is in the air compared to how much could be in the air. So in this case, we could have had 2 units of water, but in reality, we only had half of a unit. So the air was capable of holding 2 cups of water. The amount of moisture in the air was only half a cup of water. So half a cup is what percentage of 2 cups? So it'd be like 1/4 of that, right? So half a cup is 1/4 of 2 cups. If we were to kind of make that 4 cups and 1 cup, it'd be 1/4. So the relative humidity here would be 25%, because this half a cup is 25% of these 2 cups. Now, I want you to really be mindful is that relative humidity is always a percentage, from 0% to 100%. It's rarely 0 in nature. It's always above 0. And it can't be above 100%, right? You can't have 110% relative humidity. 100% is the maximum. So be mindful of that. Now, as I mentioned, the thing that affects how much the maximum humidity you can have is the temperature. So in these 3 examples, we have the specific humidity. How much humidity is in the air is 1 cup. However, what's different is that these are at different temperatures. That when it's 86 degrees, then the air is capable of holding 1, 2, 3, 4, 5 cups. There's 1 cup out of 5 cups. So the relative humidity is 1/5 or 20%. Now here the air is a little bit cooler. It can hold less amount of moisture. The maximum humidity is now 2 cups. You have 1 cup out of 2 cups, that's half. The relative humidity would be 50%. Now as the air cools down even more, now the air is only capable of holding 1 cup, right? So we have 1 cup of water out of 1 cup, 1 out of 1, that's 100% relative humidity. And it can't go above 100%. That's as much as it goes. Now, key takeaway here, I want you to note that what's changing here is the temperature of the air. As the temperature of the air changes, it changes how much moisture that the air is capable of holding. So warmer air can hold more moisture than colder air can. Right? So you have to kind of look at this closely. These are what's in the air: nitrogen, oxygen, and water vapor. So in any water vapor being a variable gas, and with colder air, you have a certain amount of nitrogen and oxygen. You count these up: 1, 2, 3, 4, 5 molecules of water vapor. Now this is warmer now, and it's capable of holding 1, 2, 3, 4, 5, 6, 7, more molecules of water vapor. Point being, warmer air could hold more moisture than colder air can. Here's another way of looking at it. So let's say you start out with warm air that is capable of holding a lot of water, and you have this much. And note that the amount of water vapor is constant throughout this graph, right? So here, it'd be like the 5 cups, 20% relative humidity. As the air cools, the amount of moisture that the air can hold decreases. So you haven't changed the amount of water vapor, but you've changed the temperature of the air, how much moisture it can hold. Now you're down to 50% relative humidity. And then as you cool it even more, you can get to the situation where it's what we call saturation, or saturated. It's saturated when you reach that 100% relative humidity. Now, the next thing to discuss is like, well, what happens if you cool that air even more? Okay. So maybe this is another way of looking at it. So here, relative humidity is below 100%, it's 40%. And then as we cool it down, the relative humidity is increasing. When we get to this magic temperature called the dew point being when you reach that saturation level, we're at 100% relative humidity. And then if you cool it even more, you're still at 100% relative humidity, but what's happening is condensation is occurring. That once after you reach 100% relative humidity and continue to squeeze that air, it's going to release moisture. So condensation occurs when you cool the air down and decrease its capacity to hold the moisture. So on a hot summer day, the relative humidity might be 50%, but on a cool day or in a cool evening, the relative humidity goes up. So as temperature increases, the maximum humidity, the amount of moisture the air is capable of holding, goes up as well. But as the air gets colder, that maximum humidity goes down. And when you reach 100% relative humidity, that's called saturation. Now the dew point, and I can't give you a single temperature, it depends on the conditions and at the time, but the temperature at which you reach that saturation point, that temperature is called the dew point. So just to recap something, relative humidity is a percentage. Saturation is a condition. Saturation is the condition of being 100% relative humidity. And that's going to happen when you cool the air down. So when you get to that specific temperature where the air cools to saturation, the temperature is called the dew point. All right, so the air is saturated or full when it's holding all the water it can. That given temperature, it reaches 100%. And then past that, you're going to get condensation if you add more water. But typically what happens instead, you get condensation when you decrease the temperature. Okay, so another way to say that is you either change the content, you add more water to the atmosphere, but more typically what happens is that you decrease the temperature, you change the capacity of the atmosphere. You cool it down and you make it less capable of holding moisture, so condensation is occurring. Maybe a practical example of this is if you have a cold glass of ice water on a warm day, you have warm, moist air that touches the glass, and when it touches the glass, it cools rapidly, and then when it cools down, it cools past the dew point and condensation occurs. It becomes saturated, and then that moisture didn't come from inside the glass. That moisture came from the air outside the glass as it cooled down. So saturated air can hold no more water. It's already saturated. And so when it cools, that's when condensation occurs. And so looking forward, what we'll see is that as air rises in the atmosphere and cools, it's going to create clouds, condensation, and rainfall because of that change in the relative humidity. So it's an inverse relationship, meaning that when the temperature is low, relative humidity is higher. And inversely, when the temperature is higher, relative humidity is lower.